What is up, everyone? Welcome back to the Marvel Project. My name's Kiro, and today we're going to keep talking about forces. Alright, and in the last video, we saw that a force was a push or a pull. Now we're going to look at how forces change what's called momentum. Alright, so forces change momentum. Okay, and so how does this work? You need to understand first what is momentum. So I'll give you the quantity for momentum first. It's the mass of an object times its velocity, okay, and it's denoted by p. So p, lowercase p, is equal to mass times velocity, p equals mv. Okay, and we can look at what these two things are. So this is momentum, which is what we're trying to analyze. What's velocity? It's how fast it's moving. And what's mass? Well, it's the measure of inertia. Okay, and if you don't remember inertia, it's the quantity for Newton's first law. Alright, and Newton's first law says an object in motion will stay in motion, and an object in rest will stay at rest, unless acted upon by an external force. So, what's mass then? Well, it means the more massive something is, the more force is required to change its motion. Okay? So, if you have a really light thing, if you have a pencil, you can pick up a pencil and throw it really easily. But you can also catch it really easily. So you can get it to start moving and stop moving really easily. But now what if you have like a brick? Well, it's harder to throw. And once it's moving, it's harder to catch because it has more mass and it has more inertia. Alright, so momentum is mass times velocity of how much it's moving. So in other words, it's the tendency of an object to keep moving. Alright, that's momentum. So momentum is the tendency of an object to keep moving. Alright, so the quantity of momentum is mv. So momentum, denoted by small p, is equal to mv, mass times velocity. Alright, so we know this is the tendency of an object to keep moving. So if I have an object, okay, and it has a momentum going to the right, how do you make it stop moving? Okay, how does that work? Well, what we can do is we're going to analyze mv, and to do that we're actually going to analyze forces. Alright, so if we remember, force equals mass times acceleration. But what's acceleration? Okay, well, it's the change of velocity. So what if we said the average force? Well, mass is constant, so the average force is equal to mass times the average acceleration. And what do we remember the average acceleration is? Well, it's equal to the final velocity minus the initial velocity over a change in time. Okay, that's average acceleration. So what if we put that into here for force? So we know that F average is equal to mass times acceleration, average acceleration, which is equal to mass times final velocity minus initial velocity over a change in time. Okay? So we can rearrange this equation. We can distribute the mass and we can multiply out the change in time. And what that'll give us is force, average force, times a change in time is equal to mass times final velocity minus mass times initial velocity. Okay, and what do we know mass times velocity is? It's momentum. So the change in momentum is equal to the average force applied times a duration of time that it was applied for. Okay, so I'll give you an example. If we're playing baseball, all right, we're playing baseball, and the pitcher throws, throws the ball and it's moving this way towards the batter. Okay, that's the bat. Alright, and it's moving this way. The ball has a mass. It's got a mass of m, okay, and a velocity, v. Alright, so its momentum, the momentum of the ball, is equal to the mass of the ball times the velocity. So it's going to go, and it wants to keep moving in this direction because of mass. It wants to keep going because it has this momentum. So when it hits here, the bat has to apply a force onto it. Okay, that's why the batter swings. It applies a force onto it. So what does this force do? Well, the bat, okay, it's going to apply a force going in this direction for a small duration of time. So the ball is going to hit him, going to hit the bat right there, still going with a momentum in this direction to the left. But the bat is applying a force to the right. Okay, and when the bat is done applying the force, the ball is going to have a new momentum. It's going to have a new velocity and momentum. So how much force did the bat apply to change the momentum? Well, we know, if we know the final velocity and we know the initial velocity, then we know the change in momentum. And what do we know? We know a force times a time is equal to the change of momentum. So if we know how long the bat and the ball were in contact, we can calculate the force. Okay, so we know the mass of the ball. So we know the mass of the ball, and we have an original velocity minus the final velocity, the final momentum, is equal to the average force times the duration of time. So if we know the final and initial velocities, and we know the mass of the ball, then we know the change in momentum. Okay, and if we know how much time they were in contact, then we know the average force applied on the ball. Okay, the next thing, what if we don't know the changes in momentums and we don't know the average force over a time interval? But what do we know? All we know is that force changes with time. So this is time, this is force. Okay, on an object. And we want to know how much impulse was applied, how much the momentum changed. What can we do? Well, we can take the average force right here. The average force over this time interval is something like this value, and we can multiply it by the time interval, which is something like this area. Okay, so this right here is how we find impulse when the force is not constant. So if you have a force that varies with time and you want to find the average force, we know the average force is equal to the area under this graph, because that's the total force, divided by the time interval. So it's something right here. Okay, but what do you know in impulse? Alright, impulse is equal to average force times delta time. So if you multiply out the delta time, what's that equal to? It's equal to the area under the force over time graph. Okay, because you're multiplying out to find the average force, you take the area and divide it by the interval, but you multiply the interval back into it, so it's just the area under the graph.